Alright, so after our little practice and introduction to considering special circumstances solutions in the last video about problem 1, we're ready to move on to something a bit more challenging in problem 2. So again, this is another geometry problem, and if you have not watched and if you know absolutely nothing about this topic, I will be putting the link to that series in the description down below. But I think it's nothing that you can't handle, so let's get started. As shown in this figure, inside trapezoid ABCD, so this whole thing is a trapezoid, E and F are each the midpoints of AB and CD. So I'm just making these marks to show that they're equal. G is a random point on EF. Again, we have that word, random. Given that triangle AGD has an area of 15 centimeters squared, and that triangle BCG is exactly 7/20ths of ABCD. What is the total area of ABCD? So again, we know that over here G is a random point. So it doesn't mean that it has to be just right here. Remember, we either talk about putting it smack dab in the middle, or to the extremes. And I think that right now, it's easiest if we put it off to one side. So this could be G. Of course, you could also put it over here, but this is where I feel most comfortable. Okay. So now we have this triangle over here. And we have this triangle over here that's EBC. So we already know that ADG has an area of 15 centimeters squared. So I'm going to write 15. And that triangle ADG is exactly 7/20ths of ABCD. So first, I just want to talk about what we observe right here. I'm just going to trace this line. Okay. So what I'm seeing here is, right, two triangles. So one is triangle DEF and the other is triangle CEF. So they have the same bases right here, right? Because F is the midpoint of DC. And they have the same height, which means that these two triangles are congruent, which means that they have the exact same, well, they're not congruent, but they have the same area. So this would be area X and this would also be area X. So if these two triangles have the same area, it means that altogether triangle ECD would be half of ABCD, right? Half. So we know that, we know that EBC right here is exactly 7/20ths, which means that EDC right here, because since X and X, they have the same area, the whole area of triangle EDC is going to be 10/20ths of the whole trapezoid, which means that ADE's area would be 3/20ths. So we know that ADE's actual area is 15. And we know that its fraction is 3/20ths. So we would just divide to find the total. 15 times 20 thirds, right? This equals 15 times 20 thirds. Simplify that, and it gives us 100. So the total area of ABCD is 100 cm squared. Again, we leveraged what we learned from the last video about finding that key word and really shifting it to a more efficient place so we can make our calculations easier. And we really only had one equation that we needed, and that was just 100 centimeters squared. So to review, our first step was to find that keyword. Our second step was to see where this point G could go to make everything easier. Our third step was to analyze our new picture, and we learned that triangle EDF and triangle EFC have the same area. Then we identified the fractions of each of these parts, right? That was the fourth step. And our final fifth step was to do the actual calculating. So thank you for watching through Inquisitive Kids, and see you in the next